Ever wonder how AI could tackle real-world tasks, like researching a shipwreck or troubleshooting software, without strict step-by-step instructions? Most AI systems today are stuck in rigid workflows, failing at open-ended long-term challenges. Enter VeriGUI, a groundbreaking dataset designed to teach AI how to think, not just follow orders. Unlike traditional tools that only check final answers, VeriGUI breaks tasks into substeps, giving real-time feedback. Imagine an AI navigating a website, parsing HTML or configuring software, learning from mistakes along the way. Built on a partially observable Markov decision process, VeriGUI lets AI piece together clues from screenshots or code, earning rewards for solving subtasks. This encourages adaptability, resilience, and strategic thinking, key for handling messy, real-world interfaces. VeriGUI isn't just a test, it's a roadmap for AI to master complex workflows. By focusing on long-horizon planning, it's paving the way for systems that don't just execute commands, but understand them. The future of AI. It's learning to think like humans. Ever wondered how AI could navigate the web like a human? Or how a machine might click buttons, type commands, and solve problems just like you? Today, we're diving into the cutting-edge world of AI agents, digital helpers learning to interact with computers, browsers, and graphical interfaces in ways that are both fascinating and wildly complex. Let's start with the basics. These agents aren't just chatbots or simple tools. They're like digital explorers, trained to perform tasks by understanding their environment. Think of them as AI assistants that can scroll, click, type, and even reason through web pages or software interfaces. But how do they learn to do this? The key lies in reinforcement learning, a type of AI training where the agent learns by trial and error. Imagine teaching a robot to walk. It stumbles, adjusts, and gradually gets better. Similarly, these agents try actions, get feedback, and refine their strategies. For example, one study, R1 Searcher++, uses this approach to teach AI to dynamically gather knowledge, like a student who learns to find answers by exploring the web. But interacting with computers isn't just about clicking. It's about understanding the environment. That's where multimodal models come in. These AI systems process not just text, but also images, layouts, and even the feel of a user interface. Take Gemini, a model that handles text, images, and other data types to tackle tasks more like humans. Or Ferret-ui, which uses vision and language to interpret mobile screens. It's like giving AI a pair of eyes and a brain. Now, how do researchers test these agents? They create benchmarks, challenges that push AI to their limits. Projects like Webwalker and Osworld simulate real-world tasks, like filling out forms or navigating websites. And there's VeriGUI, a tool that tests agents' ability to start from any point on a desktop and figure things out. It's like giving an AI a jigsaw puzzle with no picture on the box. Can it still piece it together? But here's the twist. These agents aren't perfect. They struggle with unexpected glitches, ambiguous instructions, or complex workflows. That's why researchers are building action spaces, a kind of vocabulary of possible moves. For instance, a mouse scroll becomes a scroll action, a keyboard press becomes a keytone, and even a right-click is mapped to a specific command. This structure helps AI translate real-world interactions into steps it can learn from. Now let's talk about a game changer, VeriGUI. Think of it as a detailed roadmap for AI agents, designed to test their ability to handle long, complicated workflows. Unlike older datasets that only check if a task is done, VeriGUI makes sure every step along the way is correct. It's like grading a student not just on the final exam, but on each step of their homework. The team behind VeriGUI gathered a massive collection of human-annotated examples, like a library of real-world GUI interactions. They tested leading AI models on these tasks, and guess what? Even smart AIs struggle when tasks stretch beyond a few steps. Breaking down a complex job into smaller parts. That's harder than it sounds. VeriGUI helps identify where agents fail, like a detective tracing mistakes in a recipe. Their experiments showed that current AI agents often forget earlier steps or make errors in later ones, especially when tasks involve multiple screens or unexpected